As I looked at the guest list and the subject matter when I first got it a couple of weeks ago, I found that there were several things in there that I myself am passionate about, and one of them is our next subject matter and our next presenter. The subject is adapting nature to climate change, what we can do and what we should do. Our guest is Jessica Hellmann from the biology department, assistant professor of biological sciences. And Jessica, I think when I checked one of those weather bug things on my phone before I came in, it was 82 degrees on March whatever it is. So if you can explain why my roses are blooming in the backyard in 10 minutes, I would appreciate it.
Well, actually, you know what? It's wonderful that you bring that up. In fact, that's exactly what I was going to start with and talk about. I wanted to ask you if you'd all noticed it was hot outside today. It's pretty hot outside today. In fact, what we're experiencing right now has never been recorded. Since we've been recording temperatures, we haven't observed an event like the one that's happening now. And in fact, let me show you about this. I have a slide. Here I have a picture, a map. This map shows the deviation, so how different has temperature been in March, in the first 19 days of March in comparison to the historic average. Thousands of cities have been experiencing record-breaking heat in the month of March. And what you can see is that much of the country is upwards of 10 degrees warmer than usual. And so I put up here an example of Chicago. So let's consider just Chicago for a moment. On St. Patrick's Day, a day I know you all appreciate, Chicago had its 4th day in a row of temperatures over 80 degrees. And the last time that Chicago had 4 consecutive days over 80 degrees in the springtime had been in April in 1896. And the typical high for March in Chicago is in the 40s, same here. And in fact, April typically has on average about 1 day over 80 degrees. So we're seeing something really extraordinary. You might ask, is this climate change? That's a really important question, and the answer to that is no and yes. The answer is no, because extreme events are extreme events. Strange things happen from time to time. The answer is yes, because this is exactly the kind of phenomenon that we would expect to happen more frequently under climate change. In fact, there was a recent paper that suggested that these strange winters that we had, this warm winter this year and a quite cold winter last year, might actually be due to changes in Arctic sea ice coverage, which is making the jet stream more wavy and more variable. In fact, some journalists have a word for this. They call this global weirding. But I really want to talk to you about what climate change means for species and for ecosystems, for nature. And in fact, let's use this extraordinary March to tell you about some biological consequences. And I want to give you just a case study. We study an endangered species. It's just down the toll road here at the Indiana Dunes National Lakeshore. It's an endangered species called the Karner blue butterfly. And some USGS scientists and members of my research group have been studying in the last few days if hundreds of eggs that we put out into the field over the winter have hatched in this warm spell. And in fact, they are, much ahead of schedule. So as of March 19th, about 45% of more than 600 eggs that we'd put out into the field had hatched. And that means that hundreds of hungry caterpillars were looking for things to eat. The problem is that their food plant, this wild lupin plant, was not widely available in the habitat until about March 19th. So we think about 45% of our bugs were looking for food and they couldn't find it, at least for a couple of days. And it's possible, or our concern is that catastrophic events like this one, this mismatch of food and caterpillar, could cause populations like the Karner blue to even be erased from places like the Indiana Dunes. But this recent heat wave is just one event in a trend that has climate scientists and ecologists worried. This trend is caused by massive emissions of greenhouse gases from humans, compounds like carbon dioxide and methane. Climate models suggest that if we continue business as usual, we could end up with a world by the end of the century that's about 10.5 degrees Fahrenheit warmer than the recent historic average. Or if we started reducing emissions today, or started a few years ago, we might be able to get a world that's something like 3.5 degrees warmer. In fact, we've already increased the average temperature of the Earth about 1.5 degrees. So we could potentially avoid this catastrophic change, 10.5 degrees Fahrenheit, but we cannot stop climate change altogether, thanks to the gases that we have already emitted. In fact, the last time the climate changed this amount was at the end of the last ice age, and this had huge implications for life on Earth. And I just have an example here. If you think about a place like my example is Death Valley. At the end of the last ice age, Death Valley looked like the right-hand side of this slide. It was an evergreen forest. And today it's a desert, like the left-hand side of this slide. So when the climate changed, species moved in and moved out of this large geographic area, so that the species that we associate with Southern California today are completely different than what they were 15,000 years ago. Now this time the climate is changing. It's changing over decades. It's also the case that we have lots of things in the way, potentially, of species relocating and moving around under climate change, things like cities and agriculture. So that if these are barriers to species movement, it's possible that we'll have species that can't move on their own. So we might end up with trees that don't grow as well in the place where they used to live as they used to, or species like the Karner blue could go extinct. So I have a question for you. Should we sit idly by and let species and ecosystems degrade? Or might we want to help maybe some economically important species or some sensitive species, help them adjust to climate change when they cannot on their own? In some cases, sitting idly by may be the best thing to do, but in other cases, humans will try to intervene to reduce biodiversity loss or protect ecosystem goods and services. And this is a list of some things that we could think about doing. We call these adaptation actions, where adaptation refers to helping species and ecosystems tolerate and adjust to climate change, at least when we're able to do so. And there are pros and cons to each of these, and I don't have time to talk about them all. I'm just going to talk briefly about 2 of them as an example of the larger issues around adaptation. The first I want to talk about is something called managed relocation. Managed relocation is when you take a species from where it used to live and you put it in a place where you think it will live in the future. And you might do this to protect an endangered species or to increase timber or food production, for example. And a recent example of managed relocation is a recent study showing the possibility for managed relocation was done in the Joshua Tree. So back to Southern California, if you've been to the desert Southwest, you might have seen the Joshua Tree. In fact, we have a park, a national park, Joshua Tree National Park. And that's marked on the map, X on the map here. The problem for the Joshua Tree is that models of future climate change suggest that Joshua trees might not live in Joshua Tree National Park. And what you can see here on this map, the red areas are places where Joshua Tree live now, but the models suggest they won't be able to persist there. The yellow are areas where they are likely to live in the future, and they could get there on their own because they're close to the red spots. And the green spots are places where Joshua Tree might live in the future, but they can't get there on their own because it's too far from where they currently live. So to get in the green, we'd have to put them there. So you will notice that without the green and without the red, there's not much yellow on this map for where Joshua Tree could live. We can also use the Joshua Tree to talk about another climate change adaptation, which we call strategic resistance. And imagine that we really, really wanted to keep Joshua Tree in this park. I mean, it is Joshua Tree National Park. It's the name of the park. And the goal of the National Park Service is often to keep things how they have been historically. So maybe we would want to try to preserve Joshua Tree in the park. And there is some evidence to suggest that little Joshua trees don't like it when it's hot and dry. But it might be that we could water Joshua trees, that we could tend to them and garden them and be able to maintain a population if we wanted to exert the effort. So how do we know when it is appropriate to do each of these things? And I hope these 2 examples, you can already imagine that there could be some side effects from them. So for example, for managed relocation, maybe we put these Joshua trees out there and they take over and they choke out some other species that we value. Or maybe in trying to preserve Joshua Tree in the park, we're preventing some other species from occupying that area that might need it in order to maintain its own changing and shifting population. So to decide among these kinds of things and to think about what kind of future we want, I think that we really have 4 questions that we need to be able to answer. 2 of these questions are scientific. They're technical. They're about what is the effectiveness of different actions, and what are the consequences, the unintended side effects. We need to be able to quantify those. But look at the 3rd question. Some non-scientific things that are important. Who's going to pay for adaptation? Will we be able to afford it everywhere that it might be needed? Will it only be pursued where there's an economic reason? And who will look out for species that don't have a direct economic value? Furthermore, what kind of nature, the last question, are we trying to preserve or create? The answer to this question, I think, is informed by our view of what nature is in the first place. Let me show you 2 potentially contrasting views of nature and what role we might play in nature. The first is a very famous one. You may have seen this quote from Aldo Leopold. He's an ecologist, and Leopold said, "A thing is right when it tends to preserve integrity, stability, and beauty of the biotic community, and is wrong when it tends otherwise." This type of view might have one interpretation of climate change adaptation. Let's contrast that with a recent opinion piece in the New York Times. These authors said, if your definition of nature demands that it be completely untouched by humans, there's no nature left. But they say, this is the earth that we created. We have a duty to protect and manage it with love and intelligence. It's not ruined, and we can make it more beautiful if we work together and care for it. This might give us a very different take on climate change adaptation. I also want you to realize that adapting to climate change will be much harder. Adapting to a large climate change will be much harder than adapting to a smaller one. This is a pretty simple concept, and I illustrate this here with sea level rise. If we have to learn to live with sea level rise, it would be much better to live with 1 meter of rise than, say, to live with 6 meters of rise. And I want to end my brief presentation, a little tour of this issue, with 2 thought questions that I'd like you to ponder. One is, what is your vision of nature? And the second is, what amount of adaptation do you think is justified and appropriate? And I hope that this brief tour has given you an opportunity to think about your own role in stewarding nature in the face of climate change. And if this topic is of interest to you, I of course invite you to come talk to me about it, but there's also some YouTube video here that might be of interest. And thanks so much for your attention.
Jessica, thank you very much. And now, yes, I do know why the roses are blooming in the backyard. Yeah, it is. At least my backyard is unprecedented. I can tell you that part.